Our next question is a very popular one in GCSEs of recent time with a slight twist. A circle has equation x squared plus y squared equals 80. So straight away I know my radius is going to be the square root of 80. The centre of the circle is origin O. Point P on the circle has coordinates 2A, where A is a positive constant. That might be useful later. I can see that from the graph. Tangent to the circle at P crosses the axes of Q and R. And I've just checked that everything's labelled from the question on the diagram, but it is in this case. Work out the area of triangle OQR. So the area of that triangle is going to be a half base times height. So I want to work out the coordinates of Q and R. In order to do that, I need to find the equation of this tangent. And the way I'm going to do that is I'm going to use my circle theorem that a radius always meets a tangent at 90 degrees. So if I find the gradient of my radius, then the negative reciprocal of that gradient will be the gradient of my tangent. So the gradient of my radius is going to be my change in y, well I'm going from a down to 0, so a, over my change in x, 2a to 0, 2a. So the gradient of my radius is 1/2, and therefore the gradient of my tangent is the negative reciprocal of that, negative 2. So I know that y is equal to negative 2x plus c. I need to find the value of c. I do that by subbing in a known point. So I'm going to say when x is 2a, y is equal to a, because that's on my line. And so I have a is equal to negative 4a plus c. So c is equal to 5a. I have a problem here because I don't want the area of my triangle in terms of a. I want it just numerically. So I need to find a. And I do that by using this equation here. I know that my radius is root 80. So that is this length here is root 80. I should say 80, sorry. And I can use Pythagoras' theorem, therefore, to say this length here is 2a, this length here is a. So root 80 squared, which is just 80, is equal to 2a squared, 4a squared, add a squared. So that gives me 5a squared is equal to 80. So a squared is equal to 16. And I know that a is a positive constant, or alternatively I can see that 2a and a are both positive coordinates. So a is equal to 4. And therefore I can say c is equal to 20. So y is equal to negative 2x, add 20. That now lets me find the coordinates of q and the coordinates of r. I'm going to sub in x is 0, I get y is equal to 20, and then y is 0, I get 2x equals 20, so x is 10. So my area is 1/2 times, and then 10, which is my base, times 20, which is my height. Well, 1/2 times 20 is 10, 10 times 10 is 100 square units. And so that is my final answer. Question 19 deals with vectors. Quadrilateral OABC is shown above. You're given some information. OA is 4p, OB is 3p plus 3q, and OC is 6q. X is the midpoint of OA. So I would immediately say, well, that means that OX must be 2p, because it's half of OA. Y is the point on OC such that YC equals 2OY. That is, this is 1/3 and this is 2/3. And I know OC is 6q, so this is 2q, and then this is going to be 4q. Just helps me think about my diagram. Subsequently, express xy in terms of p and q. So I need a path that takes me from x to y. So I'm going to say xy is equal to xo add oy. Xo add oy. Well, that's handy because I know both of those vectors already. Xo is going to be 2p, but in the opposite direction, so negative 2p. And oy is 2q in the same direction, so I have negative 2p add 2q. Show that BC is parallel to XY. Well, I show that two lines are parallel by showing they are scalar multiples of one another. So I already know what XY is. I'm going to show, or find the vector BC. Now to find the vector BC, I'm going to go B to O and then O to C. B to O and then O to C. B to O is straightforward. It's the same as O to B in the opposite direction. So negative 3p subtract 3q. And then O to C is just 6q. So I have negative 3p and then add 3q. And just by looking at these, I hopefully can see that they are scalar multiples of one another. I need to demonstrate that to an examiner. So I'm going to say this is 3 times negative p add q, and then I want to multiply this bracket by 2, so I'm going to say 3 over 2, negative 2p add 2q, and therefore it's 3 over 2 xy. They are scalar multiples, and therefore BC is parallel to xy. Any sensible conclusion. You don't need to use that notation. And that's almost the end of the paper now.